Well, hello Internet, and welcome to part 7 of my C++ tutorial series. In this part of the tutorial, we're going to solve 4 more problems. This time I'm going to show you how to solve the Caesar Cipher that I brought up in the last video. We're going to learn how to solve equations for x. We're also going to cover how to create lists of primes, how to generate lists of random values, and a whole bunch more leading up into the next tutorial where we're going to start covering more advanced algorithms. And like always, all the code is available in the description underneath the video along with a transcript of the video. And I have a lot to do, so let's get into it. Alright, so last time whenever I left you, this is what I told you I wanted to have you figure out. And a couple people did, which is really cool. So what are we going to do? We are going to return a string, and this is a Caesar Cipher, is the name of the function as I defined. And it is going to receive a string, which is going to be the string that it is going to shift the characters for. And the key is going to represent how many characters we're going to shift. And then we're also going to have a bool inside of here that is going to define if we are encrypting or decrypting the string that is being passed in. Alright, so now I have to create the function to make all this work. And of course, if I'm moving a little bit too quick, you could, of course, hit the pause button or get the transcript and the code and the description. Of course, everything's free. All right, so now I got to make this guy work. So the very first thing I have to think about here is going to be the string that I am going to return. I'm just going to call this return string. And yes, of course, I'm going to be getting into object-oriented programming here. I just really wanted to get a basis for how we can go and actually solve problems to learn how to use C++ instead of just covering just basic syntax, which isn't learning the language. It is actually, just covering syntax. All right, so then we're going to store character codes for each of the characters I'm going to be shifting, and then we're going to be turning them back into letters from that point. Now what I'm going to do is I'm going to see if I am going to be encrypting or decrypting, and based off of that, I'm going to change the direction of the key. So I'm going to say, are we encrypting or not? And if it is true, I'm going to take the key and multiply it times -1. And that is going to give me the opposite direction. We're going to be shifting characters around. Okay, so the next thing I have to do is I need to cycle through each of the characters that we have that was passed into it. So, character, and get that character. And then, of course, we're going to be operating on the string. And since there's going to be more than one thing here, more than one character, we are, of course, going to use curly brackets. But then what I'm going to do is I'm going to check if it's a letter, and if not, I am not going to change it. So I'm going to say, is it alpha or not? And of course, I'm checking the individual character. And if it is a character, well, that means I can convert it. So I'm going to go and get character code, and I'm going to get the character and change it into an integer, and then I'm going to get my character code and increment its value based off of the key that was presented to us. All right, so then what I'm going to need to do is, if it is an uppercase character, what I'm going to need to do is check if the new character code is going to be greater than the uppercase letter Z. And if it is, I'm then going to have to shift back to the beginning of the uppercase letter character codes. Otherwise, I'll be going into ASCII characters that are not letters. All right, so what I'm going to do is I'm going to say if is upper, and of course I'm going to be checking the character. I'm going to move this up here because I think I'm going to get the rest of the function inside of here. So if it is an uppercase character, what I want to do is I want to say if character code is greater than, and go and change the uppercase character for the letter Z into an integer. And if it is, I'm going to say character code is going to be minus or equal to 26, so that I can move it back to the beginning of my uppercase letters. All right. Then I also want to check if I'm going to be shifting downwards. I want to make sure that I don't shift directly out past the uppercase letter A. So I'm going to say, and go and get the uppercase letter A and get that guy. And then in this situation, I'm going to do the absolute opposite. I'm going to say character code, and I'm going to add 26 to it. All right, so we got all of that set up. Then I get a situation in which I'm going to do this for lowercase characters. See, here I checked if it's upper, and otherwise I can assume that it is a lowercase character. And I can go and just copy this so I don't have to type all that out again, and then just change it a little bit. Here what I'm going to do is change this to a lowercase z, and then I'm going to change this to a lowercase a. And there we go. I have all that set up, and absolutely everything is going to be exactly the same. All right, so I'm in here, and I got to the alpha part. So in this situation, I am going to want to convert from integers to characters, and then I am going to add the new letter to the returning string. So I'm going to come out of here, and I can do that directly right here. I can just say letter is going to be equal to character code, and that's going to automatically turn it from an integer into a regular old character. And then I can add it on to the end of my return string, right like that. Very, very simple. And then otherwise, else, if it is not, where are we at here? If it is not a alpha, this guy right here, well, in that situation, you can see that lit up here real nice for me. Well, in that situation, I am not going to change it at all. I'm just gonna, and that's mainly going to be spaces and things like that. And I'm just doing this for simplistic reasons. I can just go and let the letter be equal to what it is, and then go and get my return string and add it on to the end of the string. And then I can, I don't need to do anything else. I think that's enough. And then after I have all this stuff done at the very bottom of this function, I could say return string. And there we are. And as long as I typed all that incorrect, or as long as I typed it in correctly, it's going to take me, make me a secret. It's going to turn it into an encrypted version, print that out, and then it's going to go and decrypt it and then print that out. And let's run it. And you can see right here, that is indeed what it did. It went and encrypted make me secret, and that's what the results are. And then down here, it decrypted it and put it back exactly where it was. All right, so pretty cool stuff, and hopefully you guys got that, and if not, the whole goal here is just to understand. So the next thing we're going to do is we are going to go and have the user enter an equation, and we are going to solve for x. And more specifically, what I'm going to allow the user to do is they're going to enter in an equation of the sort x plus 4. This is going to be the string input, and I'm going to solve for x for it. So I'm going to go and do like I did previously. I'm going to show you what's in the main function, and then you can pause the video and try to create it yourself. So we're going to say enter an equation to solve. And let's put a space inside of there. Then I'm going to go and do, or create a string that we have here. I'm going to call this equation and give it nothing to start off with. Then I'm going to use getLine, and I'm just assuming you know how to do this because I've done these a whole bunch of times. All right, and they're going to receive, or we're going to receive standard input and store that input into the equation. And then your job is to create a function called solve for x, and all it is going to receive is the equation. All right, so now what you can do is pause your video and try to solve that. Otherwise, you can watch me solve it right now. All right, so obviously for this, we're just going to copy this, come up inside of here and define our function, our prototype for our function. And this is not going to return anything, and it is going to receive a string, and it's going to be called equation. We could throw that right there. We're going to be able to then come in, copy this, throw that down inside of there, and start creating our function. What is one thing that we are going to need, however? Well, one thing that would be extremely useful is to go and use that awesome function that we used previously called string to vector. That is going to make it much easier for us to go in and convert our string into vector values that we will then be able to take and store. So that function, I'm just going to copy it because I made it in a previous part of the tutorial series. And you can see right here where I went and put the prototype for it, string to vector. It receives a string, and you define whatever the separator is going to be, and then you go and figure that out. And here is the actual function. Like I said, we covered this in previous parts of the tutorial series. You should be watching this in order because this tutorial gets progressively more complicated. So there is the code. I'm not going to cover how that exactly works because I covered it previously. So what I'm going to worry about instead is how solve for x is going to work. Very first thing we're going to do, like always, is we're going to come in here and we're going to get our vector equation. So we're going to go vector, and this is going to be a standard string vector, and I'm going to call this vector equation just so that we'll be able to understand what's going on here. And I'm going to skip down to the next line, and I'm going to call string to vector. And I'm going to pass in the equation, of course. And then I'm also going to pass in a character, which is going to represent the separator that we're going to have. So this is the guy we're calling here, obviously. And then what do I have to do? Well, basically what I need to do is convert my strings to integers that are going to be represented with our two numbers. So I'm going to have number 1 is going to be equal to standard and stoi, which is going to convert our string into an int. And then I'm going to go and get vector equation. Equation. Spell that correct. And remember the format that I said we wanted to have? We wanted to have, well, let's go and put a commented line inside of here. So it's going to be x plus 4 is equal to 9. And then, of course, we're going to solve for x. So based off of that, I know that number 1 is going to be a vector equation, and more specifically, it's going to be the second item in there. So that's how we're going to get that. So we're going to get this guy, 0, 1, 2, obviously. And then I'm going to go and get the other item inside of here. And let's go number 2. And this is going to be the 4th index inside of our vector. And then I'm going to go int. I have the value, so let's just go and create it. So this is going to be number 2 minus number 1, just basic arithmetic, obviously. And then I'm going to go standard and cout, and I'm going to say, whoops, x is equal to, and we're going to output our value, and there we go. So pretty simple, nice little simple function. It's just really based off of if you thought about, hey, we have this nice function we created previously that created converts strings to vectors, and you were able to use that. Either way, we're going to come in here and we're going to test it out. So let's test it. We'll go x plus 4 is equal to 9. And you can see that x is equal to 5 comes back as a result. So we were successful in creating yet another and solving yet another problem. So good stuff. And now we'll move on to yet another problem. This one is going to return a list of primes, and I'll give you a little hint here that we're going to be using a function that we previously used in the tutorial once again. All right, so I'm going to create all the code that is in main, and then it'll be up to you to solve it. We are going to come in here and check. You know what? I think I'm also going to allow the user to enter a value and see if it's prime. I think that might also be an extra thing. Okay, so that's another problem for you, isn't it now? So we're going to say number 2 check, and they're going to pass that in, and you're going to verify if that is a prime value or not. And we're going to go standard cn and save that to the variable num. Another thing that's kind of cool, somebody asked me about, by default, bool values are either 1 or 0, and somebody asked me how to make them be true or false. Well, what you can do is you can go standard cout.setf, and then you go standard iOS and bool alpha, and that will instead have your booleans be either true or false instead of 0 or 1. So just thought I'd answer that question. And then what I can do is I can go and output on the screen is, and we'll have our value that the user entered, and then we will follow that up with prime. And then after that, we will call a function, I'm giving it away right here, is prime, that's going to receive a value, and then it's going to go and output on our screen whether that is a prime value or not, but it's going to output true or false instead of 1 or 0, which would be silly. Then you have 2 functions you have to create. So this is actually 2 more problems. I should have said 5 problems at the beginning of this tutorial. Well, whatever. I said 2, or I said 4. So whatever. Now you know. So the second thing we're going to do is we're going to ask the user to tell us how many primes they want us to generate. And I'm going to keep this prime number calculation kind of simple. I know there is a little bit more complex ways of generating primes, but I'm going to keep it a little simple here for now. So I'm going to go in max prime, and I'm just going to do this, and then I'm going to say that I want to, get that value and store it in the variable called max prime. And then what we're going to do is we're going to create a vector, and of course it's going to be an integer vector, and this will be prime list is what I want to call it, and it's going to call your other function called get primes, which is going to generate a list of integers in a vector, which is going to be our prime list. And then we're going to be able to go and output on the screen that prime list of values. And so we'll just output them, simple. I don't think I have to do anything special here. All right, and there we are. So there you go, guys. You're going to have to create 2 functions. One's going to be called isPrime. The other one's going to be called getPrimes. And you can pause your video right now and give that a try. Otherwise, I'm going to do it for you right now. All right, so bonus points if you figured out that the range function that we created in a previous part of the tutorial would be a useful thing to have. There, of course, I just went ahead and put that in there since I've already covered it. Actually, we've used this function a couple times, and there is the working code for our range function. So what we want to do now, if you want to pause the screen, type that in, or like I said, get the code, do whatever you want. All right, so now what we're going to do is we're going to create isPrime, and we're also going to create getPrimes. So isPrime is obviously going to return a Boolean, and it's going to receive a number that is going to that we're going to check against. And then for the other one called getPrimes, what we're going to do for it is it's going to return a vector of integers, and it's getPrimes, and like we defined down below, it is just going to have a maximum number that we are going to check for. So I'm just going to copy this guy right here and come to here and paste that in, and we will create that. And then I'm going to get this guy right here, copy that, and paste that in as well. All right, so now we just have to create them. So like I said, I'm going to do a really simple solution to check if a number is prime or not. I'm not going to get into really complicated stuff. I'll do that later on. So what I'm going to do is I'm just going to create a simple for loop, and we're going to use our range function that we placed inside of there. We're going to start at 2. We're going to go from number -1. We're going to increment by 1 each time through, and then I'm just going to say if num modulus and n is equal to 0. Well, in that situation, if we ever get a situation in which there is no remainder, then we know that we have a number that is not a Boolean. Otherwise, if it goes through all the for loops, all those different values, we're going to return true. Okay, it's a pretty simple way to check if a value is a prime value or not. And now we'll go and we will generate a vector full of primes. And of course, we're going to go and create said vector first. And we are just going to call this vector primes. And we're going to create a for loop here, auto x. Use our handy dandy range function once again. We're going to start at 2. We're going to go up to the maximum number, and that the user said that they wanted us to go up to. And then we're going to call isPrime over and over and over again. So we'll get like this. And in a situation in which it is prime, well, we're going to add it to our vectors. So we'll say push back, of course, which is going to add that value to our vector. And you can see here just how simple it was to create something, I guess, that people could think was complicated. All right, we could save it and we can run it. And what I do, error 44. Let's see here. Use of undeclared identifier max primes. And here we have max prime. I put max primes. It should have been max prime. Okay, run it again. And everything's fine. So what we can do here first is check if a value is prime. Let's put 19 inside of there. And it comes back is 19 prime. And it gives me a value of true. You can see now instead of putting ones and zeros, it puts true inside of there. And then I could say generate prime numbers up to, hey, let's say 5,000. And you're going to see that it does that. All right, so pretty cool stuff. Hopefully you guys got that correct. And now I'm going to go into my last problem for today. And that is to come in and generate a random vector full of numbers. All right, so this is mainly two tests. It's a test to see if you remember how to generate random numbers, and also to see if you can figure out how to generate random numbers within a range. So what I'm going to have the user do in this situation, let's go into our main function, and let's create, there's going to be something you need to include to generate random numbers. I'm not going to tell you, see if you remember. So I'm going to go and create a vector, once again, integer, and I'm just going to call this vector values is going to be equal to, and this is the function you're going to create. It's going to be called generate random vec, and the user is going to be able to come in here and type in the number of values that they want, number of random values inside of the vector, and also they're going to be able to tell you at what number they want to start and at what number they want to end. So there is the trick in this. And then after that, you're just going to output them on the screen for all the world to see. And then we're going to go and we're going to output this. Just simple. And there we are. So there is your hint. And now you can pause the screen and try to create this devious little guy, or you can watch me do it. All right, so did you remember what we need? We are going to, there's a bunch of different ways. I'm going to show you a C++ specific way of generating random values. Maybe I'll do it in the next tutorial. All right, we're going to use ctime to help us generate our random values. And this guy is going to receive it's going to return a vector of integers. And its name is obviously generate random vec. It's going to receive an integer, and I'm going to call it num of nums. So the total number of values it wants. We're going to have our minimum value, and we're also going to have our max value. So now we need to create this function, and we're going to do it. We'll come down here, and we will create it. So what are we going to need to do once again? Well, we're going to very first define our vector value that we're going to be returning. So of course that is integer, and of course I got that from right here. That's where I got that. All right, so I want that, and that's going to be vector values is what I'm going to call that. And then what I need to do is I need to generate my seed. So I'm going to go srand and time and null. If you don't know what that means, it's just going to allow me to generate random values based off of the ever-changing times, okay, which is the number of seconds since January the 1st, 1970, I believe, off the top of my head. Okay, so we have that generated. Now what we're going to do is we're going to create an integer I is equal to 0, and then we're going to have random value also equal to 0, and let's go and create more of this stuff. I'm going to generate a while loop here, and we're going to continue cycling as long as, I already did create I, as long as I is less than the num of numbers that it wants me to generate. And then comes the complicated part. Well, you know what, let's go and increment I inside of here. Now comes the complicated part. How am I going to come in here and generate this random value in the range in which I have here? Well, I'm going to go random value is going to be equal to. Then what I'm going to do is I'm going to put min inside of here. And min is going to be added so that we're able to increase the results of our overall random value. So got that set. Then we need to actually create our random value. So we'll go rand, just like we did previously, and we'll go and get modulus of, and then we need to correct. So whenever we do a modulus, like I said previously, the remainder of the modulus can't possibly be greater than the divisor, and that is what max is going to be. But I need to also correct for the fact that min is going to, need to be subtracted off of the max. So we're going to have a minimum value, but then we're going to also make sure that the max never goes over the max amount. So we're going to go +1 on that. And then after this, we're going to subtract out the min that we previously added. So that's how we can create that. And then what we can do is go and get this random value, and we can push it onto our vector that we're creating here, and random value. And I is going to be incremented, and the only other thing we're going to need to do is we created our vector. So we'll go vector values and return it, and we'll run it. And you can see it went and generated a series of random values that generated 10 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And they all fall between the values of 5 and 50. And if I run it again, you can see there it is, and there it is, and there it is. So hopefully you guys got something like that. And like always, like I said previously, in the next part of the tutorial, I'm going to get into algorithms like bubble sorts and sorting procedures and things like that. And of course, I'm going to cover object-oriented programming, of course. And like always, please leave your questions and comments below. Otherwise, till next time.